Okay, now let's look at a lens problem. It's a little bit different than a mirror problem, but it still uses those same formulas. So in this case, we have the height of our object is 4 centimeters, and the distance, so that's the distance of our object, is 10 centimeters. And then it says the image is 13 centimeters behind the lens. So that's going to be our image distance. And that's going to be positive. So, for example, if they had said in front of the lens, then it would be negative. So you just kind of have to, again, you can write that stuff down. You don't have to memorize that. So the first thing they ask is, what is the focal length? So we're going to use this thin lens equation. And in this case, we're looking for the focal length, and we have the DO and the DI. Okay. So I like to turn them into decimals. I think it's just a little bit easier, but you don't have to. And again, that's 1 over F. That's not F, right? If you get some teeny tiny number, that usually is a good indication that, like a number less than 1, that's a good indication that you haven't solved for the focal length or the image distance or the object distance yet. You still have to do that 1 over part. So just a little kind of reminder for you, a way to tell. So that's our focal length, 5.65. Okay, and let's go and let's do the next part. See how that goes. So the next thing they want is the magnification of the lens. Okay, so our magnification is equal to okay, so it's either one of these. So we've got DO and DI, so we can go ahead and solve for that. It's going to be negative 1.3. And that's going to be our I should have done that. That's going to be our magnification. So that tells us it's larger. Okay. And then the other thing we want to do is the last 2 parts is they want to know if it's real or virtual. So here's how we figure that out. For the real and virtual, we want to look at this image distance. Is it in front of the lens? Is it behind the lens? What's going on? So in this case, we have a real image because it's behind the lens. Okay, and then for part D, the way to tell whether an image is right side up or upside down is to look at the height or the magnification. And basically, if it is if the height is negative, but HI over HO, if that's negative, then it's going to be or this image height is negative, you're going to have an upside down image. Or if that magnification is negative, you're going to have an upside down image. So we'll say upside down, and I'll write a negative. Okay, and that's how you solve those type of problems.